Well, this may look a bit dramatic, but I am sucking all the old refrigerant out of my water chiller for the aftercooler. I'm just burning it off so it's not going to collect on the floor and possibly explode. So I'm just sucking it out, and it's going along the pipe. It's coming from the refrigeration compressor in here, and it's going along into this one. It's coming out there into the suction on here to give us a better vacuum, and it's been just burned off here. And I'm just going to refill this compressor here with propane. That isobutane refrigerant is quite smoky when it burns. It's almost like burning oil. But I'm surprised at the amount of stuff that's coming out of this. Must have been a heck of a lot in there, a lot more than you'd think. It's still burning a big flame like that yet. The refrigeration compressor for this water chiller is actually still running. It still seems to be frosting up, so I think we've got a wee while to wait until this flame dies down. There's certainly a lot of stuff. And it's still going. This is about 2 minutes later and still quite a big flame coming out there. Who would have thought that that little compressor held such a lot of refrigerant? Now that we have a decent amount of propane in it, I've noticed that the capillary tube, I used to only freeze up to about here, but now it's freezing up way back here. So I think if I shorten it a good bit to about there, and then just remove this section, I think it'll reduce the temperature it can reach. No, sorry, it means that it won't chill to as low a temperature, but it'll be able to move more heat. That's what I believe shortening the capillary tube does. I'm not exactly sure about that. I believe longer, thinner capillary tubes are used if you want lower temperatures and you sacrifice some thermal capacity with that. But for this, I'm really wanting it to like chill the water down to about 0 degrees Celsius, so I think if I shorten that tube a good bit, it should do that and let me transfer the heat faster, and it'll not get as cold, and then result in freezing up the air coil inside here, and then blocking the outlet of the compressor and then causing it to overload. But I'm now noticing as I'm adding more refrigerant, the frost is beginning to move away from this side. And the power consumption just now is at 73 watts. I think it's actually performing better than it did on R600A. I don't know what the long term effects will be. It might damage the compressor over time, I don't know. Propane does have, well, just barbecue propane, that's what this is. It does have more moisture in it than refrigeration grade stuff. But it sure sounds good now. It's making more noise than it used to. The compressor temperature as well, there's no cause for concern. It's still cold. It's been running for well over 10 minutes now. The bottom of it where the oil is, the whole thing is still cold. And the power consumption is really about the same as when it was running on R600A, so I really like propane as a refrigerant actually. It's really cheap. think another day what I'll do is a bit of a silly experiment where I'll take the copper coil off and then just replace it with some clear PVC tubing, and you might be able to see the liquid boiling off inside, because well, evaporator temperatures, as you can see, it's pretty much 0 psi, so I don't think pressure will be an issue. It might leak slightly, but it'll be a fun experiment to try. And we're down to -10 Celsius. Maybe that's the reason they slap R600A on the side of that, maybe because they don't want people putting propane in them. I doubt that's the reason, but who knows really. Propane works just as good, and hopefully it should last a long time. I don't think that the mercaptan in the propane is going to be that much of a problem, because it doesn't really seem to smell all that much, which is a bit unusual. Well, the temperature is now pretty much off the scale, down below -10. Can't see that very well, but it's down below -10. It's all nice and frosted up. I won't be running this cold obviously when I'm running the compressor, but I'm just testing just now. And yeah, so £35 for this, and that's about, I can't remember exactly, that was close to £15, that little bottle there. So yeah, propane from now on. I think I'll repurpose this as a refrigerant reclaim pump, and then what I could do is, once I've got the natural gas out of this, I suppose I could just store it in there. That could be my receiver for it, because I'm planning to make a natural gas or propane powered generator, and I was wanting to test some natural gas in it while I've still got some left. Now, as you can see, it's just a service valve adapter on there, and this is still compressed up to 40 bar. Now I'm going to turn it off, and we'll see what the pressure rises to. There's a plug the water pump as well. I'll pause it just now and I'll wait until it stabilises. Well, that's 30 psi almost, so the pressure when it's off is quite a bit more than it used to be.